Good morning, everyone. My name is Sumithra Bhojan. I'm with AT&T, and I work in the converged access and device technology part of the business under labs. Today, I'm going to be talking a little bit about a specification that AT&T contributed last year, and this is fairly a simple update. So what I'm going to cover today is on the open programmable OLT specification. This actually introduced the use of FPGAs into our, into the OLTs. And I don't know if you're familiar with that specification. It was submitted last year in the October timeframe. And here today, I'm going to, meaning I'll kind of give you an overview because some of you may be new to that specification. Right now, trying to broaden the scope of the silicon option as well. As you've heard before, the main purpose of the specification is to be a little bit agnostic to the silicon. Here, I think, we had a number of ASIC options before for XGSPON, XGS, and then we introduced FPGAs. But again, this specification will include some ASIC option as well, just to be inclusive of all the silicon. And then we'll touch upon a fronthaul transport, some questions we get about why we need this hardware to be programmable to the next generation PON. And that's one of the use case that we in AT&T see that as coming in the near future. So, like I said, a little bit of update on the current specification. So this is a high-density OLT box. We previously had 16 ports, and we put in the spec for a 32-port XGSPON, which is basically a 10 gig by 10 gig services, with future support to upgrade to a 25 gig PON when that becomes available. This uses SFP28 for these PON interfaces, and then the uplinks are using the 8 QSFP, which is basically 4 by 10 gig or 4 by 25 gig lanes. The one new thing that we also did in the spec is we removed the local aggregation. The reason being AT&T is moving towards an disaggregated OLT implementation in the central offices. And later today, you will hear from ONF on a project called SEBA, which is a SDN-enabled broadband access. And we have been partnering with several operators and suppliers in working with the ONF community in that disaggregation approach. So in that case, this box would fit quite well into that architecture because that will have an aggregation switch. The idea is to not have these in every OLT, but in fact have the top-of-rack aggregation switch support multiple OLTs. So that way you kind of don't have that redundant function everywhere. That reduces power, cooling, and also cost for us. And the remaining, I guess, points are pretty standard for an OCP. We will require redundant and field replaceable power supply units and fans. Again, nothing new, just reuse of what we have in other OCP white boxes, use of BMC and an optional CPU. The spec calls about a couple variants of hardware. This is more or less a form factor, and it's really left to the operator on how they plan to deploy. Typically, I think the more popular one is the 1RU 19-inch that goes on the 19-inch rack. That's kind of what we have in the central office today. So, if you're not doing a huge infrastructure upgrade, I think that fits well. But when you move towards a data center type of implementation, in OCP, we do have CG19 racks. And if that becomes a viable path, this can also be, made in a form factor of a 2RU half-width sled to go into those CG19 rack. So it's kind of a modular design that will fit into any form factor that an operator would want to deploy in their network. So this is kind of the update to, it's a functional block diagram introducing an ASIC option into the spec. Since we did the, I guess since I introduced it last year, there is an ASIC from Broadcom, it's called the Aspen, that does 16 ports of XGSPON, and it's 25 gig capable. So I think having 2 of these silicon will fit quite well into the 32-port box requirement. The remaining components are pretty standard, no other changes. Again, so this basically, the specification would have both an FPGA and an ASIC option, and I think that is kind of the true value here, based on what you would deploy. And again, the FPGA, the reason we introduced is we want it to be comparable to what's available in the market, right? The FPGA also will have standard IPs that will, that's more or less comparable to an ASIC option. So in our mind, it's the same. The version, a note here is, I guess the version that the Aspen is today, which is sampling, will only provide 2 ports of 25 gig PON. So I do want to caveat that because the specification does require about 8 ports of 25 gig PON, which is pretty much half the density, but that's kind of in the pipeline with the next release. So going a bit into the future application, 25 gig PON is probably a little bit ways out, and for a residential services using PON, XGS, which is a 10 by 10, should take us quite a few years, right? Meaning we still have GPON deployment going on for many operators. So XGS life is definitely a long period, but the use case for a 25 gig PON is very different. Obviously, the standards work needs to be completed, which we expect maybe by end of the year. And here we're looking at a possible front-haul transport. Mike covered the CAS. That is obviously, what we would require for a CPRI to eCPRI and so on. This is a little bit more expanding, right? Meaning our networks are huge, and this gives us another way to provide transport using PON. And obviously, with the way PON is today, that cannot be met, or we cannot meet the latency requirements of the 125 microseconds. And there is an effort going on in the standards between ITU and ORAN on what they call the cooperative DBA that will help improve the latency. So once that's in place and meets the latency requirements, I think this PON box would kind of broaden the scope and be used for front-haul transport as well. A little bit of an update that I don't have here is the kind of an update from an ODM, AD-Link, they're not here today, is that we do have a prototype available using an FPGA. It's a Xilinx FPGA that's being used with the IP provided for the XGSPON. And it also has a Volta adapter that we plan to use for the CIBA disaggregated OLT solution. So I think I'm excited to hear that with the evaluation unit, and hoping to see a product pretty soon, later this year. That's our goal. And also with the 25 gig PON, this is out to the ODMs out here, that we are also very interested in having a prototype this year for the 25 gig PON and be able to demonstrate the front-haul transport as well. So that has been one of our key initiatives for AT&T this year. So it's kind of, I'm just, if there are interest, if you want to reach out to me, we can talk more about that. So like I said, it's a fairly simple update. Please, reach out to either, via the mailing list or email me. The specification is available in the wiki. So take a look and provide me any feedback. And I would love to hear from the ODMs on product availability as well. Thanks, and I'll take some questions. I think we have some time.
So I know you presented this box, and it has sort of a similar interfacing from a faceplate perspective to what Mike has presented in his CAS rack mount. I know the switching and other capabilities would not be there. Would you envision that a box that addresses this and some of Mike's needs coming together would be good for you guys? Is that sort of convergence where?
That's a very good question. I would say, let me say a little bit of a personal view and a company view, right? Meaning these are going in the central office, meaning the form factors. So I think what Mike presented is very much a product that we want to see, and it's more so, I would say, driven by the environments and where it is deployed. I think it fits well, meaning into a cell site. This exact specification may not fit into that particular use case, but in a hub location or a central office, I very much see some type of a convergence, right? Meaning this could be, like you said, very much a multi-use box that can do PON as well as the support CPRI and eCPRI. Especially with the FPGA design, we do have that flexibility. And as we develop the CAS solution, it would become much more clearer, but this is definitely an option that we will consider for a central office or a hub location.
Flexible and modular. Okay, perfect. Thank you.
Okay. All right. Thanks for your time today. Thank you.